till the last class, we basically worked on creating database, creating schema, creating table, whether it is row store or column store. Then we've seen about global temporary table, local temporary table. Then about partitioning the table with hash or range or round robin. Yeah. So can you also partition the table with the UI also? You right click on the table folder or the schema, then you get an option called show table distribution, and then you just carry on from there. Right click and can you add a partition later on? Can you also drop a partition? Good. And when it comes to range partitioning, you can go over doing it on date wise, month wise, or year wise. Okay. Then we have focused on altering the table definition. There's one property which can be handled only from the alter step, that is preload. So if you want to set the table for preload, you must handle it from the alter. While creating table, you cannot control the property. It has to be controlled from the alter table statement. Preload all, preload certain color. All means what? All the columns of the table. It is full load. When you load only certain columns, then that is what? Partial load. And whether the table is switched on for auto merge or not, what is the unload priority, whether it has been switched on for preload entire table or partial preload, all these settings or properties can be looked at in a table called tables. There is a system table called tables which can show you all those properties being enabled, right? Good, okay. Now we'll focus on database view. Let's focus on database view. Let's say, now why do we create a database view? Let's say you got data in multiple tables and you would like to join those tables and get the single view of it. That's where we go with database view. In normal BW or ABAP applications, we used to go with SC11 and you just give a view and say create, you just choose it as database view and go about doing it. So basically you'll have to have multiple tables and you join them and create a view what you want. That's the data. We are not discussing an HANA model. No, it's not attribute view or analytics. This is normal database view. Okay. So when it comes to creating database view, you can go about creating this with SQL statement, or it can also be created with the UI also. Now let's take a simple example and then I have a table called, I have a schema Cubex SQL, and then I've got two tables here. I've got a table called customer. You can see that. I can right click and say what? Open definition. And I get to see the columns here. Customer ID, city ID, country ID, region ID, company name, customer name, country name, and some region. So this table gives me for a given customer what is the region name, what is the company name. Company name is nothing but name of the customer for me. City, country, and region. And what is the primary key in this table? There's no primary key, that's fine. And then I have a table called fact sales. Okay. Now let's see the content of this table. I just got number, integers all this, and then name of the company, city, countries, and region names. Okay, good. Now we have a table called FCT sales, which is fact sales, which is basically a transaction table, and each if you look at this, what is the primary key? Order ID, product, and customer ID. And actually this is the item level database. For one order, when you receive an order from the customer, can we see order for multiple items? Yeah, it says for a given order, what is the product and who is the customer, and you just get to see net sales and some quantities. Okay, so now my requirement is for a given, I just want to build a view which gives me for a given company name, or let's say for a given region or country, what is my net sales or net sales and quantity sold. So I've got customer ID here. Based on this customer ID, if I can join the customer table, I can get those columns from both these tables and join these two tables. Great. and I would like to do that by creating a database view. Okay, is my database view virtual? Yes, or virtual. Very good. So only physical medium storage of data will be tables. Okay. Now let's get in. What is my schema? 8 cubics. First, let's create with the UI. Select this view folder. Right click on this view and say what? అంతే ఆడ ఆప్షన్ దొరుకుతుంది అన్న వెళ్ళిపోవడం అదే చెప్తుంది న్యూ వ్యూ yeah, and then what is specify is what name of the view, yeah? Let's say you want to have it as customer sales or something, okay, or region sales. And I want to create this view in what is this, in which schema do you like to create this view? I want it on 8 cubics. Now in the canvas here, you can start specifying the tables what you want and establish the join condition between both. Now right click and also insert tables, or even in the by using this icon here you can drop down and say what, insert table. Either way you can do this. I'll say insert table. You're referring to the table customer and FCT sales of which schema here? Cubics. Cubics. Cubics SQL, and from this which table? Customer. I can just select control and choose multiple tables at a time. Sure. Sorry, overhead table. Sir, insert one more table and I would like to insert what? Customer tables. I've got these two, and I would like to establish the join between this. So I have this fact sales table, which gives me customer ID. For more details of customer, I'm joining to a customer table. So what you do is you try joining from this table from where you need and to the table which can give you the information. So select this column and connect this to what? This column, customer ID. And when you drag and drop, it formats a join. Now it will ask me what is this here? What type of join you want? When you say none, it is inner join. And when you drop down, you can say left, right, full. So when you say none is what? Inner join. Inner join means what? Only the common values from both the tables. And when you say left outer join, it brings the common values plus unmatched values from the left operand. If you say right, matching plus unmatched values from the right operand. When you say full, it's all A plus B, matching values, unmatched values from right and unmatched values from left also, right? So I can format a join this way, or I can also do this, right click and say insert and say what? Join. It opens up a dialog box where I can formulate the join. So from this table, I would like, what is this here? Left table is my sales and right table is my customer, and choose a common columns what you want. So this says fact sales dot customer ID is equal to customer dot customer ID. So this is equal to just like normal. This is like inner join. If you just leave it like this, if I select checkbox here, then this becomes what? Left outer. And if I select this checkbox, then this becomes right outer. If I select checkbox on the both the sides, then this becomes full outer. Okay, I'm okay with inner now. Say okay. Like this, you can format join either way, either by drag and drop or anything. I'm okay with none. Then once that is formatted, what all you should choose the column names. I want the region name to be outputted. Then I want country name. Then from this, I want net sales. I want quantity. If you want, you can basically control this column properties. Like, so you want to give a different name. You want them to be sorted. I want this to be sorted in descending. I want this name as the region. I want this not. This should be as country something. I just want to rename that column. And I also want this also to be so. First, it sorts on the region. Within the region, again, it sorts on the country. I can do all this stuff. Yeah. And then say what? What is it? Active. This is about creating view. You could the bug activation at Lantern, no good. Just say. So my view is ready. You see, this is the view. You can just right click and say open content. Now, when I say open content, it is basically going to read all the data from the underlying tables and give me views. Right? I can also see the definition of it. So what is it? Open definition. These are our columns which have been outputted from this view. And if I say there's some like create statement, so it says no, create view. This is the syntax of it. Sorry. What is it? Create view and the name of the view. And we just specify the select statement which has to result me this saying select region from table 1, country from table 1, net sales from table 0, quantity from table 0. First reads from fact sales and inner joins this to what? Customer, and on what? What is the join condition? Customer ID dot is equal to customer ID, and makes order by. You can also use a subquery or subselect statement to formulate my view. Even if you do with UI, it is going to formulate the definition in the backend and formulate a view for you. Okay. Now, same thing I would like to do with SQL by using SQL. I'll just go in. Now, take it this way. You remember I have two tables, customer and FCT sales. I want to choose some columns from both of this. First, let's formulate a select statement which can give me the result, what I want. Then I'll go with view. Select. I just want to read data from two tables, right? What is the column name you want? Select or always column name, table name, try to put double quotes. Not mandatory. If the column name or table name has special characters, then double quotes is mandatory. Otherwise, no. Yeah. The region name. Then what else you want? Ultimately, you won't read what? I want to read region, country, then what? Net sales, then what? I customer reading game. Customer reading join this, but I'm not reading it as a projection. Okay. I want to read these four columns. I'm just say select the columns what you want to read. Anyway, I'm going to come to the statements later in detail, but for now. So I'm just to select and list out the columns what I want. From which tables do you want? Is it from a single table or multiple tables? The columns what I'm reading, is it from single table or multiple tables? See, multiple tables, right? These two are from one table and these two are from a different table. So two tables. So I'll say from what is this? Schema pair. Cubics SQL dot what is it? FCT sales is one table. Okay. Good table in this. Cubics SQL dot customer. This is another table for right. Now, when I'm reading this column, should I clearly specify that these two columns should be read from which table? Customer table. And these two columns should be read from which table? Fact sales. Then should I say, so to clearly indicate the system from which table it should read, should I say like this? Table name dot region. So system understand, okay, region name must be read from customer table. And company name must be read from country table. And what about this? Fact sales should be from where? But the table is really big. Instead of specifying repeating the table name in the entire select, what I would do is I would go with alias name. I'll say, I'll set this as T1. I'll call this as T1. So when you just specify some table name as this, it is an alias name. So in the entire select, I can either use this table name or I can use this T1 as a table. And then I want to set this as T2. Now instead of repeating the very big name, I can say T1 dot from region, sorry, customer. Customer is what? T2. And this also what? T2. And what of net sales? T1 dot T1. Okay, now I'm going to read these columns from two different tables. Read it from fact sales, and also to the customer. While reading from the fact sales, I should join to the customer tables. At the fact sales data read this while reading data from fact sales, it has to execute the join to the customer table and then read this. I'll say from this fact sales. So inner join this table. Read these columns from this table 1. While reading from this table, it has to join to table 2. What join? Inner join. Same thing if you want to go with left order, then I'll say what? Left order. Other right order, right order. Full order, full order. It's only specifying join. Right? I'm okay with what now? Inner join. Okay. Okay, you said while reading data from table 1, it has to join to table 2. Right? On what? When you want to read data from fact sales, you would like to join the data to a different table, customer table. But on what column do you would like to join? Customer ID was, right? So how do you specify it? T1 dot customer ID is equal to T2 dot customer ID. That's it. Okay. Let's see what does this query give. And if you select this and say execute, syntax error near T1. Either. No, 1 second. On. Means for the join query, on what? On which column you'd like to join this? Perform inner join on this. On which column? That's it. For table alias, you don't have to put as good. Next, what I want this. I would like to do sorting on this region. Yeah. For sorting, what will I do? I'll use what? Order by. Order by which column you would like to sort? You can still be very specific on what you want. Region name. Then also want it to be done on first region wise, and within the region again I want sorting on the country. I use this order by, and by default it goes with ascending order, or I can also say ASC. When I say ASC, it is what? Ascending. And if you want to go with descending, I will say DESC. That's how by using order by control the sorting option. So I'll come in detail later. Okay. Select this and 6. So I'm getting this Asia Pacific. Within Asia Pacific, first one is what? It's going with Japan, and if I go bottom, only Japan on syllabus. Okay. And almost Japan. Now what? Next, what I want is you see these duplicates. But there are multiple transactions performed in Asia Pacific and Japan, so it is showing me all the duplicates. But I want that to be aggregated. What I want is, I want this net sales and the quantity to be aggregated with respect to region and country. I want the aggregation to happen. Normally, when BW specify aggregation, sum of, max, min, all those stuff, same way, I would specify this. And so what? Sum of. While reading the data, I would like to aggregate my net sales, say sum of this, and then what? Sum of quantities also. Now, are you specifying the aggregation function? You are aggregating the measures like with sum or min or max, average or whatever it is. When you're doing this, you must specify group by function. Now, see, I've got 4 columns, right? Now you specify aggregation function for how many fields? How many columns? 2. Not all. You must perform the group by based on all the non-aggregation columns. It's mandatory. Yeah. So I'll say, and order by must be the last statement of the SQL. Then I'll say what? Group by what? So I would like to do group by region name and country name. And then while reading, how many number of columns we have for non-aggregation fields? All of them must be specified in the group by. So now I see only one record for Asia Pacific and Japan, A, E, L, and then within A, you got J, S. Now it's been sorted ascending. First region wise, within the country, within the region, countries have been sorted. Fine, boss. Now I would like to use this select results and create my view, boss. Create a view. You want to create view in which schema? 8 cubics. This is my view name. And then you formulate the select step. So I'm saying create view so and so as with all the sub select statements. Select which is going to result with the view definition. So once the view is created, I should see the view here. This is my view. I can see the content which shows my aggregated values. And I can also see the definition what we have formulated also. You can see the sum and that stuff. Okay, boss. So you can go to creating. Can I join 3 tables, 4 tables, 5 tables? It will be same logic. So you say inner, you'll say table 1, inner join this table 2 on this. Again, you will say what? Inner join table 3 on so and so condition. Again, inner join table 4 on this inner or left join on. You can go for joining multiple tables also. Okay. So this is about creating a view. Okay. Next, synonyms. Let's go with synonyms. It's very simple. Synonym is, you can understand like alias name for a table, or we can understand it as a shortcut to the table. If you don't want to group, is it possible through saying if you want to group the data, is it possible through GUI? I think it should be. I think you can. Select control. I think in select you'll have control, but not at this place. Yeah. In the graphical, you don't have the option of doing it. Okay. What be a performance issue here if you use more than 3 tables for a join? You're saying if I'm joining 3 tables, will you have performance issue? We're using HANA because it will not have a performance issue because it's an in-memory database. It should join the tables. That's the concept because of column store table. Okay, next synonyms. You can understand synonym as a shortcut to your table or alias name to the table, to a database table. Not only to table, I can create synonym for a procedure, or I can create a synonym for a view. For most of the database objects, you want to provide a duplicate or alias name or a shortcut to that name. Then you can go with synonyms. First, let me see how do we create a synonym, then we'll see when do we use it. For example, tables. I have a table. I have this table employee, and I would like to create a synonym for this table as EMP. Even when I refer the table name as EMP, it must be referring to this table employee. Almost like a shortcut. On a desktop, the shortcut create this. When I click that, it gets down to the same file, same way. When I create a shortcut with the naming as EMP, which is similar to employee, when I do a select on my EMP, it actually fires employee. That's it. That's like alias name or a shortcut, whatever you can refer to. So how do I create? Here UI లేదు. It has to go with normal SQL. For creating synonym, you don't have with the UI. It has to be done with SQL. Now select this and say what? Very simple. See, this is all DDL statements. For creating table, you're using create table. If you want alter, you're saying alter table. Same way, if you want to create a synonym, I'll say what? Create a synonym. If you want to create a view, I'll say what? Create view. Yeah. Synonym spelling SYNON. Create synonym. Okay. You would like to create this synonym in which schema? 8 cubics. And what is the name of the synonym you want? EMP. For what? For what? You can type in or you can just drag and drop the table. That is it. Create synonym and the name of the synonym what you want for which table. So can you create synonym only for table, or can I create synonym for a procedure? Can I create synonym for a view? Can I create synonym for a trigger? Yes. It's for most of the database artifacts, you want to create a shortcut name, then we go with what? Synonym. Okay. Cannot duplicate. Already EMP ఉంది. I'll say EMP syn anta. Okay. So you have this synonym here. See, and icon చూసి నువ్వు చెప్పాలి మామూలు షార్ట్ కట్ ఉండే సింబల్ అంతే. If you just right click and say open definition, you can still see that. It's a synonym name is EMP syn, created on which schema 8 cubics, and for which table it is. This is the one. I'll come to this checkbox. This checkbox called public also. Okay, fine. This is about creating normal synonym. Now, is this synonym created in which schema was? 8 cubics. So only the user who has got access to the schema 8 cubics will be able to access this synonyms. Only the user who's got access to the schema 8 cubics will be able to use this synonym. So that I read from synonym, otherwise no. Yeah. And if I'm reading data from synonym, it is actually going to show me the content of what? I'm reading from this, but it is actually showing me content of the table employee, a shortcut. But I can only do read only if I have select authorizations on the schema 8 cubics. Otherwise, no. Okay. So next, there's one more type of synonym where you can set it as public. You remember there is a checkbox public. We can also create this is I can say this is local synonym for a schema. We can also create public synonyms also. I'll say I use a keyword. Using this keyword is about enabling the checkbox public. Create public synonym. So when I say public synonym, it does not belong to any of the schema. It is global. Okay. So it does not belong to any schema. So I'm going to remove this schema. If I say 8 cubics, it means it is specific to that schema. But when I say public, it is no way belonging to any schema. And I'll say public underscore EMPSYN. Okay. And representing for the same table. I'm creating a public synonym or another public shortcut for this table. For oh no. See, the table is The table employees of schema 8 cubics. But the synonym what I'm creating is not in any, is not specific in any scheme. It should be public. That's it. That's the point. And select create this. Now once the synonyms are created, with which one is public, you will see a folder at the top. As look at this, in under catalog folder, you see another folder called what? Public synonyms, and all the public synonyms are shown there. Okay, now I can right click on this and show open definition. You see the checkbox what? Public, and right click and say what? Open definition. Sorry, sorry, ಇದು ಅದು ಕೂಡ ದೂರ ಹೋಗಿ ಸರ್. ఇక్కడ schema ఏమంటుంది was public అది. Okay, I can also see the data. Ultimate refers to employee table. So what does this mean when you say public? Any user, now the user need not have access to schema 8 cubics. Any user who's got login to the is able to log into HANA database can basically consume this public synonym. Public and global, everyone will be able to consume or access that. If you have some tables about holiday, list of holidays or factory calendar tables, which you want to make it global and make sure everyone has got access to that, then you can make public synonym for those kind of tables you can focus on. Okay, factory calendars, gani, holiday calendars, other information you want to make it global to every user, then you can make it as public synonyms. Okay. Now the question is, why should I create this synonyms? Now, why it's about shortcut. Now, can I create synonym for a view? Can I create synonym for a procedure? Yes. Now, why should I create this? Okay. So you can look at multiple options. Now, the first option is, let's say I have some application built on HANA database. Let's say it is BWs. Okay. And you've written some ABAP programming where normally when you look at application development, database design and application programming will be done simultaneously, because database will be done for a different person and front-end application will be designed for different person. Let's say he was given specifications where he has to write a programming as if it is reading from a table called EMPs. But the database person assumed that the table was supposed to be, a table name was supposed to be employee, and he created a table with what? Employee, that was already used in a lot of stored procedures and a lot of views again. Now, if I need to correct this mistake, so the only option is what? Either I should go over changing all my application programmings, replacing EMP with what? Employee, or change my table name back to what? EMP. Either things I should do, which might be, we might have a lot of impact analysis on it to be done and then do. Instead of doing that, what I can do, can I create in the same scheme, I'll create a synonym saying EMP for the table. Then my programs would still work on that. That is one requirement. That is okay. Next kind of requirement. Now do you know about currency conversion in BW or even in ECC? In ECC, you use some standard function models when you want to convert currencies from one currency to another currency. Even in BW, you can still use function model, or you can use some standard functionalities of BW to do currency conversion or unit conversion. Okay. When you use the standard function model of ABAP to do currency conversion, from which table does it take the exchange rates? There will be some standard table, T-cur, it picks the exchange rates, T-cur-C, it picks the codes, T-cur-F, it picks up the fractions. Atla unnai kada ante nenu neeku cheppale nuvu andru ote word cheptunnavu ante it's a standard mechanism of all SAP applications which would refer to the standard tables of currency relevant tables like T-cur, T-cur-C, T-cur-X, T-cur-F, and does the currency conversions. If it is unit conversion, it would refer to the tables like TW6, TW6B and konni tables, and it leverages those standard tables for unit conversion. That is the standard mechanism in all the SAP applications, whether it is BW, CRM or UCC, whatever it is. Right? Clear? Even in HANA, even in SAP HANA, when you basically execute this SQL functions or some CE functions to perform currency conversions, your standard functions would expect to read currency conversions from the same table with those namings. Even when I do currency conversion using SQL statement, about function like convert currency, or even if I use some CE function, there's also a CE function available for performing currency conversion. When I do that, when I do currency conversion either by using the SQL function or CE function, the function is built, the coding of the function is with C++, it is built such a way that it would refer to the tables, standard tables of currency conversion like tcur-C, tcur-X, tcur-F, and tcur-bus by default. Standard programs of currency conversion in HANA are also designed in the same way as ECC or BW to refer to the standard tables with the name which are named as tcur, tcur-X, tcur-F, all those stuff, right? But let's say now I have a scenario like this. I've set up HANA and I'm replicating database from a non-SAP system to HANA bus. Let's say I'm setting up HANA native or an enterprise HANA where I'm just basically replicating data from non-SAP source. In non-SAP, the exchanges could be maintained in some different table, like say exchange underscore rates, currency underscore conversion. The table names could be different. What you would have maintained the tables on his naming whatever he wants, right? Let's say you replicate all those tables into HANA, right? When I'm trying to do currency conversion in HANA, it will ask me in which schema do we have those currency conversions on. When I specify that schema, it says I don't find a table with tcur, I don't find a table with tcur-F, I don't find a table with tcur-X. So in that case, what I can solve this problem like by creating synonym. I'll say what create synonym tcur for exchange underscore rates table. Create synonym tcur-C for list of currencies table. Can I do that? Solve with synonyms first? So the standard functions programs of HANA database would need tables in certain naming. There are certain application programs like that. For all those programs, if you have a different naming of the tables, I can use the concept of synonym and rename those or create a shortcut to them. So నేను అలాగే ఉదాహరణ చేసిన so I have got a schema called SAP HANA demo ఉంటుంది. In that I've got lots of tables. I also have a tables relevant for currency conversion. Look at this tables. In table చూడ what is the table name? sap.hana.democontent.epm.data.::epm.conversions.tcur. అది నా complete table name. But actually standard function of my HANA database, which is supposed to do the currency conversion, would expect to see the table with naming as well. It would search for the table with naming tcur. So it says there's no table for currency conversion rates. So what I've done, look at this. I've created synonym saying what is tcur. Tcur in this schema, referring to which table? This is a table. Can that be a scenario for handling synonyms? It's almost like it's a shortcut to your database object. You can create normal schema or public schema. You can create normal synonym or local or public synonyms. Next, indexes.
Part of a table structure cannot be
From synonym. Can you create shortcut for a part of the file? Okay, next, indexes. Now, do you know about secondary indexes? You know about primary index, which is the primary key, but we can also use second indexes. Forget about second indexes of the cube. If it is older version of BW or normal ABAPers, what they do when you see some select statements are really slow on a database table, you go to S11 and can I create a second index on the table? You see a button at the top as indexes and you create a second index on the tables. Yes or no? That was normal. Even in BW, when you're trying to do a select on a ODS active table, when it was slow, we used to create indexes on this active table of a DSO in older versions straight away from S11. But now in the new versions, he has given a flexibility to create index from the UI, and in the DSO definition itself, we can create index. Now you don't have to go to S11. But even if I do it from the ODS definition, it actually creates a second index in S11. Any other doubt? Okay, the question is, can we have multiple synonyms for one database object? Yes. Can you have multiple synonyms for one data? Yes, but one synonym for multiple objects? No. Okay.
Can both the people access at a time?
Only both.
only ఇద్దరికి యాక్సెస్
2 years వాళ్ళకి ఇస్తాం ఎట్లా ఇవ్వాలన్నట్టు. I told you when you're saying I got scheme, I need to give authorization to only 2 users. I said in the user maintenance you have a tab called object privileges, and that is how you have to control the users. Can you please explain? No tension. See, don't worry about how does analytical view does the conversion. Irrelevant of this. When we get on analytical view, we will do current. It's very simple. In analytical views, you'll have you'll have a tab called columns. You can just select this column and say there's something called semantics. You can get to semantics and then do current. If it is SP8 or 9, if it is 7, you have to go about creating say new calculated column. Take this measure and then you'll have a tab called semantics. You have to get into this and say enable for conversion and then do. చెప్పబోతే నాకు రాదనుకుంటూ చెప్తే టాపిక్ డివైడ్ అవుతుంది, అది ప్రాబ్లం. This is no way relevant for analytical view. Okay, we'll come to analytical view later, don't worry now. Okay. Next, indexes. I was discussing on second indexes. In SC11 lo index create cheyochu kada, same way. Even see, if you're working on BW on HANA, you can still create your second indexes by going into SC11, no issues. If you're working on ECC on HANA, you can still create indexes by getting on SC11. So if I'm just working on plain HANA or native HANA, I don't have any ABAP applications running on top of it. So I'll have to explicitly create index on my table from HANA database. So even by logging into HANA database, I can create second index on my tables also. Simple. Create good column, very, very simple about creating index. But question is, why do I need index? That's the question. Creating the navigation part of creating index is very, very simple, very easy. But do you understand second index? Apart from the primary key, I'm trying to create second index to improve my reading performance on the table. Ultimate purpose of indexing is what? To improve the reading on that. Yeah, good. Now you remember in the beginning classes, I told you in a column store table, each column itself will act as an index. Then why do you want to create index? That's the question. If it is normal databases, they were row store tables, so you went about creating the second indexes. But in case of HANA, we are using column store table where each column itself is acting like an index, right? Then why should I create index? That's the question. Okay, Nana, fine. Now look at this. We'll come to this index type later, but there is a PowerPoint by SAP which tells you on indexing explicitly on HANA database. First, let's understand what if index is created, how does it look like? If there's no index, how does it look like? It says clearly in a column store, every column can be considered as an index. Since each column acts like index, most selects are sufficiently fast without index, additional index. And each column is acting like an index. Most of your select statements or most of the read operations on a table are pretty fast. But still, then if that is the case, then why should I think about creating second index on my table? That's the question. Then what I want to, then a major point what he focuses is, if you're writing more of OLTP kind of selects, and selecting star, and you say you're trying to read complete record and having more where class, more specific where class, okay, and you're using more of CPU usage is more, then I would go with creating second index. Normal analytical, when you use a table for analytical operations, you just read only some columns of a table. Normal OLTP reporting and OLTP purpose and what was my sales order, who created it, when it was created, what was the time it was created, what was the date it was changed, what was the time it was changed. It will be more very detailed processing on it, a detailed record. Right? It's almost like select star from a very big table. And moreover, you're not going to read more records. You just read certain record or particular 2-3 records. So when you want to read, when the table has got a lot of data and you want to read only certain record, Then you put lot of filter conditions in the where class, where this is where field 1 is so and so, where 2 is field 2, field 3, field you put lot of filter conditions. And then if that is the case, the data what you're reading is really less. But the amount of time you're spending, the amount of memory usage or the CPU usage is huge. For this kind of selects to improve performance, you go with what? It's additional creating second indexes. Fast గానే ఉంటుంది కానీ CPU time ఎక్కువ వాడుకుంటుంది. అలాంటి దానికి you have to go with what? Creating additional indexing. Okay. Now just try to look at this. This is a case. You remember in a column store table, each column is stored at one memory locations. And for storing, does it use dictionary-based integer coding? I told you a compression technique. In HANA database, it does store in column store. Each column is stored in one memory locations, and all the column store tables are stored in dictionary-based integer coding. They use that concept compression technique. Until ultimately, what are the values we have? For each distinct value, they assign one integer value. The dictionary-based integer ante oka alphanumeric value oka integer formulate chesi aa integer base మీద positioning indexing పెట్టుకుంటాడు. Now look at this. I've got some column called city, and if I just store in column store, it will still have this in dictionary integer coding saying what? For each of the city, it maintains one what? Integer number. And this is like positioning indexing. And in the A row lo A city వాడినాడు అన్నట్టు. I told you in a column store table, each column is stored in one memory location. But how does it know which column value is linked to which column in other memory location? Positioning indexing adi. So this is a dictionary coding saying each alphanumeric value, distinct value will be assigned with one integer number. And then you'll have a positioning sequencing index. Sequence and positioning indexing. Row 1 ki A number, row 2 ki A number, row 3 ki A number. So if that is stored, now let's say I would like to read all the records of city, something like New York. It goes to the dictionary coding. Okay. And then based on the dictionary coding for New York, it does find out the number as what? Integer number as what? Which is a numeric number 772. And then it goes to the positioning indexing and scans through. It goes to positioning indexing. Let's say you've got 1 million rows. All 1 million rows have to be scanned to see the records of 772. అంతే కదన్నా ప్రతి రికార్డ్ చూసుకుంటూ పోయి ఏ రికార్డులో 772 ఉందో చూసుకోవాలన్నట్టు కదా. ఇప్పుడు చూడు, now we have formulated some inverted index. What does it happen? Now look at this. New York City so it maintains an inverted index now, which says for each of the integer number, it does maintain the list of all the rows. Row number 1 or A rows map anni rows and number anni పెట్టుకుంటుంది. So now when you search for city, first it goes to the dictionary coding, finds out what is the numeric value associated with New York. Then it goes to the inverted index based on the associated integer number 772. It finds out the list of rows which have to be considered for New York. New York సంబంధించి ఏ rows ఉన్న కనుక్కుంటుంది. Then it goes to this positioning indexing and reads only those rows directly. Okay, Nana? First, when you search for New York, based on the integer coding, it finds an SID column type almost. Numeric integer coding is almost like your SID. So based on your New York, it first finds out what is the corresponding integer number for it. And based on the integer number, it will have inverted index, which tells me for this integer number, what are the associated rows. Pick all the associated row numbers and then straight away reads data from those rows. Are the inverted index. Okay. And there is also something called normal second indexes. Concatenated index and there's one more set of indexes called concatenated index. We'll come to that later, but still for now let's say you have a table. Can I have a primary with multiple columns? Simple example. Just understand this logically. Say I have a table with mat, plant, 9 columns. And I've set both mat and plant as primary keys. Okay, let's say I've got two records, M1, P1, M1, P2. Okay, two records. But internally, what it does when you have composite key, it formulates a concatenated index which actually stores value M1, P1, M1, P2. Concatenated values పెట్టుకుంటున్నాను. You getting what I'm saying? Let's say I have a table called mat, and I've got a plant, and I've got a column called something else. And where mat and plant both are primary. When I activate this table internally, by default, it maintains one more concatenated column, which is mat plant. You have metal separate, plant column separate, but again it maintains one more concatenated column saying mat plant, which stores concatenated values of both metal and plant. M1 P1 కలిపి M1 P2 కలిపి పెట్టుకుంటాడు. That is called as concatenated columns. Then what is the importance of, see, if you use concatenated column, then go to it will affect your database space, memory space ఎక్కువనట్టుగా, because it stores metal value in metal column, plant value in plant column, as well as concatenate both column values and stores in another column. Is it occupying more space? But improves my join performance. Space is ఎక్కువ వాడుకుంటుంది, అదో లిమిటేషన్ ఉంది, but it improves performance. ఇంకో పాయింట్ ఎక్కడ ఎక్కువ యూజ్ అవుతుందంటే, in what way will it improve performance? చూడు, నాకు I have a table with mat and plant are primary keys, and since these two columns are primary key, by default it will have a concatenated column saying mat plant ఉంటుంది. Okay, now ఈ table ఏముందంటే mat, I've got one table with mat, plant, and there's a column called color, 3 columns, and mat and plant are the primary key. Since these two are primary key, we'll have a concatenated column as what? Mat plant. Oh, that is one table. Let's say I've got another table which says orders, sales orders. I've got order ID as a primary key, and I've got metal, I've got plant, and I've got sales. And what is the primary key in the second table? Order ID, single column. Now what is that? I would like to join these two tables with based on what? Mat and plant. We get this flexibility only when you join on multiple columns. Now what is it? I say T1.mat is equal to T2.mat, and T1.plant is equal to T2.plant. I am performing join on 2 columns here. Instead of doing that, for the second table also, if I can generate concatenated index or concatenated column saying what? Mat plant values together, then I can say what? T1 dot concatenated index is equal to T2 dot concatenated index. Obviously, when you perform join on single column and when you perform join on 2 columns, which is faster? రెండు కాలమ్స్ మీద జాయిన్ చేసే బదులు కాంకేటెడ్ కాలం మీద జాయిన్ చేసుకుంటారు. అది దాని కాన్సెప్ట్. అలాంటప్పుడు దెన్ యూ గో విత్ వాట్? కాంకేటెడ్ కాలం. ఐ కెన్ షో యూ దట్. రిమెంబర్ అదర్ డే వీ క్రియేటెడ్ మ్యాట్ ప్లాంట్ టేబుల్. మనం చేసినాం కదా. ఐ క్రియేటెడ్ మ్యాట్ ప్లాంట్ టేబుల్ with that mat and plant both are primary key columns, right? Now I would like to show you those concatenated column by primary key composite key default concatenated column ఉంటుంది. So I can show you. I would like to select star from, you'll have view called m underscore cs underscore all underscore col columns column. This is ready-made view, systems view, which will tell me list of all the columns in a table. ఒక table లో columns ఏమేమి ఉన్నాయో చెప్తుంది అన్నట్టు. What is the table name? Mat plant, and schema underscore name is equal to 8 cubics. అంటే ఈ టేబుల్లో ఈ స్కీమాకి సంబంధించిన కాలమ్స్ అన్ని చూపి అని చెప్తున్నాను. నేను చూస్తాను అయ్యా వేరే ఎత్తేసిన వేరే లేవు సార్. చూడమ్మా, అబౌట్ మ్యాట్ ప్లాంట్ కలర్, దీస్ ఆర్ ద కలర్స్ వాట్ యు యాక్చువల్లీ సీ. Apart from the columns what you see, there are some hidden columns in the table. One is row ID. Do you remember when I tried to see open country, it shows row numbers 1 2 3, and that is row ID, which is a built-in column. When I basically say employee table, right click, open country, row number కనిపిస్తుంది 1 2 3. This is actually row number from hidden column there. So no build చేయకపోయినా, even if you don't specify, by default every table will have a row ID column, system column. There's one more trex UDIV or column ఉంటుంది. Trex underscore UD. This is like unique key for every record in a table. We don't worry, that's all used by trex. We don't worry on that. ఇది. See, there's another column called trex external key. This is a column which actually holds the concatenated attributes of both. చూడొచ్చు కావాల్సింది. ఫర్ ఎగ్జాంపుల్ let me just insert some record ఏదో ఒకటి. మెటల్ ఇంటీజర్ పెట్టినట్టున్నా. మెటల్ ఇంటీజర్ ఓకే. 1 ప్లాంట్ ఏం చేస్తా P1 some color white. ఇది 2 కన్ఫ్యూజ్ అవుతా ఉన్నా. సో ఐల్ సే 99 88 ఎందుకంటే 1 2 వేరే నంబర్లు ఉంటాయి. ఇది black. Like this I'm inserting 2 records into it. Okay. If I have 2 records in this table, should I be able to read those data from the table? Just select star from which table? Mat plant. Okay, get this. Say mat 88 90. Apart from this 3 columns, I also want to see the hidden column in the backend. So colon, comma, then what? Dollar text external key. So I also want to see that also from this table. So 99 P1 kada. In the text external key, what did it store? 99. Don't worry about the 2 in between. So 99 P1 is a combination. 88 and P1 is a combination. That's concatenated index. If it is composite key, by default this is formulated. If other tables where those are not part of private, we will have to explicitly create those concrete columns. I'll tell you that later. While modeling, we have that options. While creating model attribute view or article view, we have a checkbox called generate concatenate attributes. We'll see that option. Okay, boss. Is it concatenated values and other? Mat plant key, right? Yes. If mat plant a key, by default it creates it. But if mat plant are not key, but you still want that to be, you want to create a concrete column, use it for joining to a table where mat plant is a primary key, then I'd explicitly generate those concrete columns. Okay. Okay. That's fine. Just take this note. And when you basically install your database application on HANA database, there will be no second indexes at all. And for more detailed information about indexing, we have to go to this note 1794296. Program this is note will just give you details of standard programs in SAP applications running on HANA, whether it is BW on HANA or ECC on HANA. There are some standard programs delivered, one for analyzing, one for creating. We can use one program. If you run through, it checks those tables and suggests you on which table, which column the second indexes must be created. And there's one more program to create that also. Let me open 1794297. So see, this note is only useful for SAP applications running on HANA. HANA lo table create this because in HANA as it is, you will not have any ABAP program. Okay. You just read this note, but mainly it's like this. You see a program SHDB_index_analyze. So if I have a BW on HANA system, I can run this program to check whether are there any tables which would need to have the indexes created for it. ECC on HANA, any ABAP system on HANA. And same, దీంతో కనుక్కుంటాం ఏ దానికి అవసరం ఉంటుందని. And when I use this program SHDB_index create, it will create those second indexes, whatever is required of the tables. Okay. This is for what? SAP applications running on HANA. If it is normal HANA, I go about creating index straight away like this. Okay, I take this employee table. I have this employee name and department number. Let's say department number is not primary key, but I see a lot of queries running on department number and I want a second index on this table. Then what do? You go, first say what is say edit. Okay, go to the tab called indexes. So add some name. ఇక్కడ type, ఇక్కడ index type లో ఒకటి ఉంటుంది. This like normal index type is not like normal index. There's one more thing called full text index అని ఇంకోటి ఉంటుంది. This full text index is generally used for processing for unstructured data. When you want to do sentiment analysis, that stuff we use that. So we'll come to the topic, but I'll just show you one index. On which column you want unique index or non-unique index? I want non-unique index and what? Department number and say what? Execute. This is like creating your indexes. If you select the checkbox unique, it creates unique index. If you deselect, it creates non-unique indexes. Okay. I can also create with the SQL statement also. Good. See, that's how you're creating indexes. Okay. But there are two types of indexes which it creates in HANA. One is CPB tree and B trees. CPB tree and binary trees. When you create indexing in the UI, you don't have option of controlling the type. When you just create with the UI, system will identify what is the best one to create. If you don't specify any type, system will find which is suitable and it creates the type of index on its own. But there are actually two types of second indexes. One is CPB tree and B trees. First, a difference in binary tree. You know what is binary tree? Okay, I give you values like C100, C200, C200, C300, C400, and C500. I number list. Assume there are huge values, and then what do? You organize them in form of a binary tree. Binary tree and a parent with two children, right child, left child. Right child is always greater than. You organize that, and you basically get a tree with five nodes. And at every comparison, you are nearing half of the probable to the value. అంతే కదా ఒక్కొక్క కంపారిజన్ తో హాఫ్ ఆఫ్ ప్రాబుల్ నియర్ వెళ్తావు అన్నట్టు అంతే కదా. సరే ఇట్లాంటిది ఇచ్చిన అనుకోండి. అసలు ఇట్లే చాలా ఉన్నాయనుకున్నా. అజ్యూమ్ ద లాట్ ఆఫ్ వాల్యూస్ లైక్ దిస్. ఇప్పుడు ఐ టెల్ యూ సర్చ్ ఫర్ దిస్ వాల్యూ అంటుంది. ఏంది REQV 125 సెర్చ్ చేయమంటే ఏం చేస్తాను? I assume the lot of values like this, and I'm asking you to search for this string, this value REQV underscore 125 MNBN and this. If you are intelligent enough, how do you search this? More even in BW, when you're trying to look for request number, మొత్తం చదువుతామా వెనకో ముందు చదువుతాం. You try to observe the last three characters or first three, and then try to identify whether it is different or same or something. నేను కూడా అంతే. ఇప్పుడు ఏం చేస్తానంటే I'll try to create index only for this part of the string only. REQ underscore 123 or 7 characters కే నేను ఇండెక్స్ బిల్డ్ చేసుకుంటాను. దట్ ఈస్ కాల్డ్ ప్రిఫిక్స్ బైనరీ ట్రీ. CPB tree అంటే ప్రిఫిక్స్ అంటే you only take the prefix of the string and create your index. You just take a prefix of the string and create a binary tree. That is called a CPB tree. If you take complete value and create indexing, that is binary tree. If you just take only prefix of the string and create your binary tree, that is called a CPB tree. Okay, fine. Now just try to take the create index. We can also create index with SQL also. With UI, you know what? Go to index tab, create also. You can also create indexes with SQL also. But creates index on a table. Okay. See, when column data types are character strings, binary strings, and decimal types, and when the constraint is a composite key or a non-unique constraint, the index type is what? CPB tree. Non-unique అయిన string data types కన్నిటికి CPB tree build చేస్తుంది. In other case, B tree will be used if neither B, in other case, it uses B tree. And if the data type is integer or if it is unique, న్యూమరిక్ అన్నిటికీ బి ట్రీకి వెళ్తుంది, బిగ్ స్ట్రింగ్ డే టైప్స్ అన్నిటికీ సిబి బిట్కి వెళ్తుంది అట్లా. బట్ ఇఫ్ యూ డోంట్ స్పెసిఫై ఎనీథింగ్, HANA database will choose appropriate index type automatically. అదే చూస్ చేసుకుంటుంది. But while creating with UI, you don't have flexibility of controlling the type of index what you want. But with this skill, you will have it like this. So now I'm showing you how do we create index with SQL. So I'm just creating a table with 8 cubic so and so, and then with employee and employee names. It's great, and I have this table. What is EMP simple? This is my definition of the table. And do I see any indexes here? No. So I'm going to say like this. I'll say you can either go to UI and say create index from there, or else I can say create index, some name of the index what you want, on which column. But here I never specify that is unique. But if you don't specify unique, it is by default what? Non-unique. And I also never specify the type of index also what I want. So by default system will choose a type suitable index for. Index name is a column is created. Is it unique? No. So next one more table. EMPIND. EMPIND. And do I have any index on this table? No. Now what I'm saying is, I'm saying create. You can use this keyword unique to specify that index to be unique. And if you want to control the type of index, you can use this keyword CPB. So by using SQL, you can control explicitly. I want this type of index. I want CPB tree or B tree index and the name of the index on what. These two keywords unique and index, whether you want unique or non-unique, and type of index what you want. You say this, and you see the checkbox unique, but you don't get to see whether it is CPB tree or B tree. If you want to see that, there will be standard tables which will show you information about all the indexes. There is a table called indexes, index underscore columns, and render ready-made system tables, which will give you information about all the indexes. Tables and a standard etundo. Same way, all the metadata of indexes are stored into these tables, indexes here. And that's okay. Instead of specifying some type of index, you can also go without specifying anything. If you don't specify anything, system will decide about what type of index is suitable for that column. Okay, boss? This is like about normal second indexes. There's something called full text index. We'll get back to that later. That's about, like, say I have some reviews on some product, and I would like to use those reviews and analyze how much was my positive sentiment on this product, how much was my negative sentiment on this product. If you want to go doing that kind of stuff, then we get in the చూపిస్తా. Data level. I thought if there are some reviews, we can just build some simple index and see how does it build. The concept we can always build it. You just go say full text index. It will ask me something called configuration. There are some ready-made there's some concept called text analysis. There are some ready-made configurations which will have dictionaries already built in by SAP. You just have to use the dictionaries and build the full text index, and this full text index will give you some table, text analysis table. On this text analysis table, you can get all those sentiment analysis. Let me see that. Okay. Fine, boss. We'll stop it here for today. And there's also there's also option of altering the index also. Altering index, and it's not about changing the definition of the index. It's about rebuilding, refreshing those indexes. And it's alter index so and so rebuild it. You're basically refreshing those. Let's say you deleted data, and then I reload it. I want to refresh my indexes. I can say alter index. Okay. Trigger. We'll see. So we'll see that tomorrow. We'll stop it here. Okay. We'll continue tomorrow. So any doubt?